At the centres of most galaxies, including our own, lie supermassive black holes, objects millions or even billions of times the mass of the Sun. We see them already formed less than 1 billion years after the Big Bang, and that presents a problem. Because according to our best models, there simply hasn't been enough time to grow something that large through conventional processes. So how did they form so quickly? That question has been open for decades, but recently something happened that may offer a clue. If confirmed, it will be a major step forward in our understanding of black hole growth in the early universe. So what happened? Before we answer that, there's another question we have about black holes, although it concerns stellar mass black holes, those born from supernova explosions rather than supermassive ones. The question is this: why have the 3 current gravitational wave observatories, the 2 LIGOs in the United States, Virgo in Europe and Kagra in Japan, detected far more black hole mergers in the 10 years since the first detection than scientists' models predicted? Now, it may sound unlikely, but there's possibly a connection between these 2 seemingly unrelated questions. How supermassive black holes in the early universe grew so much so quickly, and why we've observed many more mergers of black holes than predicted, may have the same answer. And that answer leads us to an amazing discovery, and in this video we're going to embark on a journey to a quite unexpected destination, where that single answer to both questions may have been hiding in plain sight, because we never thought to look there. Let's address the second question first. Why have we detected far more black hole mergers than predicted? After the first merger of 2 stellar mass black holes was detected in gravitational waves at LIGO in September 2015, astronomers created computer models of how many such mergers would be detected in the next 10 years. Combining data from that first merger with mathematical simulations of black holes merging, they arrived at an approximate figure. Astronomers expected to observe up to 50 black hole mergers in the next decade. However, in the decade since 2015, the 3 gravitational wave observatories, LIGO, Virgo and Kagra, have detected around 300 mergers, 6 times the predicted number. How could astronomers' computer models have got it so wrong? The answer may be that astronomers did not have all the information they needed to make an accurate prediction of the number of mergers. There was something they didn't know about. It wasn't until 2024 that they got their first glimpse of what that something was, and that glimpse could also be the key to unlocking the answer to the question of how supermassive black holes grew so fast in the early universe. Because in 2024, an event happened which was unprecedented. Plus, according to the laws of physics, it should not have happened at all. So what was that event? In November 2024, LIGO, Virgo and Kagra detected a gravitational wave event. Later designated S241125N, it looked at first like a standard black hole merger. 2 compact objects spiraling together, merging into a single, more massive black hole. But then, something unexpected appeared. Just seconds after the merger, a burst of gamma rays was detected. Then, hours later, a telescope in space detected X-ray emissions from the same area of sky. This was extraordinary, because black hole mergers are not supposed to produce light. When 2 black holes merge, there's no explosion, no flash, no release of electromagnetic radiation at any wavelength. There's no matter, no fuel, nothing to radiate. And yet, here it was. A black hole merger that lit up the universe. To understand exactly what had happened, astronomers needed to know if the gravitational wave event and the gamma and X-ray emissions were indeed related or just coincidence. And for that, they needed to know exactly where in the sky the gravitational waves and the emissions which followed it had originated. When a black hole merger is detected through gravitational waves, it's not possible to pinpoint an exact location on the sky. Instead, we end up with a broad region of the sky, sometimes hundreds of square degrees, and somewhere in this vast area, 2 black holes had merged. But when the burst of gamma rays was detected seconds after the gravitational wave event, it immediately narrowed the search, reducing the possible location to a much smaller region. Hours later, a space telescope detected X-ray emission from the same part of the sky. And X-ray observations are far more precise, tightening the localization even further. The true location must therefore lie where all three signals overlap: gravitational waves, gamma rays, and X-rays. And right at that intersection is our candidate, the most likely place where this black hole merger occurred. Which raises a crucial question: what was there at that location in space that could produce light? If the merger had happened in empty interstellar space, there could not have been anything present to produce it. Therefore, the merger could not have happened in empty space, but in an environment where it had interacted with matter to produce the gamma and X-rays. Astronomers now started to work out in what type of environment the merger could have occurred. The gamma and X-ray emissions were so strong that there had to have been a lot of matter for the merger to interact with. This led astronomers to the only environment that fitted the bill: an active galactic nucleus, or AGN. An AGN is the bright, energetic core of a young galaxy with immense energy at its center. Where does that energy come from? At the center of an AGN is a supermassive black hole, millions or even billions of times the mass of our Sun. As matter falls towards the black hole, it forms a hot, rapidly spinning accretion disk, consisting largely of gas but also other material which may have been captured by the extreme gravity of the supermassive black hole. That disk can outshine the entire galaxy. The extreme brightness is generated by the material and gas in the accretion disk heating up to perhaps millions of degrees and glowing brightly, particularly at X-ray wavelengths. Some AGNs are so bright we call them quasars. So a quasar is not something different from an AGN, it is an especially luminous type of AGN. All quasars are AGNs, but not all AGNs are quasars. Depending how much material in the disk the black hole is consuming and how quickly, the black hole may also produce jets, its immensely strong magnetic field focusing infalling matter and gas into jets of plasma which may extend for thousands of light years across the universe and contain the energy of 100,000 stars like our Sun. These jets can influence the evolution of the whole galaxy as they slam their way through hydrogen clouds, dispersing them and preventing them collapsing to form stars. The environment in an active galactic nucleus is extreme. The accretion disk is hot, incredibly bright, and turbulent. Close to the black hole, the gas in an accretion disk can be whipping around at a significant fraction of the speed of light, perhaps hundreds of thousands of kilometers per second. But it's in the extreme environment of an AGN's accretion disk that we may have found something truly amazing, which could answer our questions about early supermassive black hole growth and the number of stellar mass merger detections being higher than predicted. And here's what we think we've found. Inside the accretion disk, smaller objects, stars, neutron stars, and even black holes, can become embedded within the gas. So a natural question is, where do these smaller black holes come from in the first place? Some were likely already living in the crowded heart of the galaxy long before the AGN disk appeared. Over time, heavy objects tend to drift inward, gathering near the supermassive black hole. When the accretion disk forms, some of those stellar mass black holes pass through the gas repeatedly. That gas acts like a brake, draining orbital energy and gradually pulling them into the disk itself. But that may not be the only source. AGN disks can also be rich enough to form massive stars. Those stars live fast, die young, and may collapse into new black holes already embedded in the disk. So we end up with ancient black holes captured from the galactic center and newly formed black holes born inside the disk. Either way, the result is the same: a steady supply of black holes entering one of the most extreme environments in the universe. Once there, they begin to interact with it, exchanging energy and momentum with the surrounding material. And that interaction doesn't just disturb them, It causes them to move. As these objects move through the gas, they interact with it continuously. The disk exerts forces on them, exchanging energy and angular momentum, and that causes them to migrate. Some drift inwards, others outward, slowly changing their orbits over time. But this migration doesn't continue indefinitely. At certain distances from the center, the forces from the surrounding gas balance out. Inward and outward torques cancel. And where they do, these regions are known as migration traps. And here, objects begin to accumulate. As more and more objects migrate into these regions, the density increases. Black holes begin to crowd together. And in this environment, encounters become inevitable. Now, it's worth pausing here. This idea of migration traps isn't based on a single event. It comes from years of theoretical work supported by computer simulations showing how objects move through accretion disks. And there are growing hints from observations, including an unexpected population of heavier than expected black hole mergers. But we haven't directly seen a migration trap, not yet. What this event may represent is the first time we've seen one in action. And crucially, it does it far faster than we'd expect. Instead of taking hundreds of millions of years to grow, mergers in these disks could build larger black holes in just tens of millions of years. As more and more objects migrate into these regions, the density increases. Black holes begin to crowd together. In these crowded regions, black holes pass close to one another. Some pairs become gravitationally bound, forming binaries, systems that will spiral together and eventually merge. And when they do merge, something important happens, because unlike mergers in empty space, these occur inside a dense gaseous environment. Energy can be transferred to the surrounding material, shocks can form, gas can heat up and radiate. In these environments, black holes don't just collide, they grow. Migration traps gather them together, drive repeated mergers, and build ever more massive objects. These disks may be the missing link, the factories that helped create the universe's largest black holes far earlier than we thought possible. And crucially, this process doesn't just work, it works fast. There are therefore possibly two fundamentally different ways to grow a black hole. The first happens inside these dense accretion disks, through repeated mergers. Black holes are drawn together, form binaries, collide and merge, leaving behind a more massive black hole each time. And if that remnant stays inside the disk, the process can repeat, again and again. This is stepwise growth, building larger black holes through a chain of mergers, and it happens on timescales of just millions to tens of millions of years. But this isn't the only way black holes grow. The more familiar process is accretion, slowly feeding on surrounding gas. In this case, growth is steady, continuous, but fundamentally slow. It takes hundreds of millions, even billions of years to build a truly massive black hole this way. So what we're looking at here is a stark contrast, two pathways operating on completely different timescales. And this difference turns out to be critical. When we look back into the early universe, we already see fully formed supermassive black holes less than 1 billion years after the Big Bang. That's a problem for slow, steady growth alone. There simply isn't enough time. But there's another constraint here. These black hole factories, the accretion disks and migration traps, don't exist from the beginning. They only form once galaxies and their central black holes, the first AGNs, have already taken shape. This was about 1 billion years after the Big Bang. So the clock doesn't start at the Big Bang, it starts later, making the race even harder to win, which makes the timing problem even more severe. But mergers inside these disks change the picture. They allow black holes to grow rapidly, on timescales of tens of millions of years, rather than hundreds of millions or more. And that may be exactly what we need to explain how the universe built its largest black holes so early in its history. If that's the mechanism, then the next question is, what does that growth actually look like? Because black holes don't jump straight from stellar remnants to supermassive giants. They have to build up, step by step. We begin with stellar mass black holes, the remnants of massive stars. These typically contain a few to a few tens of times the mass of the Sun, and in environments like these accretion disks, they don't remain isolated. They orbit, interact, and slowly begin to influence one another. But in dense regions of the disk, those interactions become much more frequent. Black holes pass close to one another, form binaries, co-orbit, and eventually merge. Each merger produces a more massive remnant, one that can remain embedded in the disk and take part in the process again. And this is where growth really begins. Over time, repeated mergers build something new. Intermediate mass black holes, larger than anything a single star can produce, but still far smaller than the giants at the centers of galaxies. These objects bridge a crucial gap and may represent the missing step in black hole evolution. But you might be wondering where this entire process ends. Does the AGN end up with two supermassive black holes? Well, the answer is no, so let's see what happens. Firstly, black holes form in a migration trap, then merge again with other black holes. Over millions of years, repeated mergers form intermediate mass black holes, which then merge with each other, creating an even more massive black hole. As that black hole grows larger and heavier through repeated mergers, its growing mass means it's pulled more and more inward by the central supermassive black hole's gravity. It migrates inward through the accretion disk and merges with the giant at the center. At the centers of most galaxies, including unleash the fire and fury of our planet. We fear them, but often cannot predict them. We marvel at their primal beauty, their immense destructive power, their ability to reshape landscapes and change lives forever. Volcanoes remind us that we live on a living, dynamic planet, always changing, always creating and destroying. The Earth surely had to be the only place in the solar system where volcanoes could exist, the only world so dynamic and energetic that it could breathe fire. But now we know that view is untrue. There are many places in the solar system which have volcanoes. On some of these worlds, the volcanoes do not spit fire, but ice. A moon of Jupiter rages with more than 400 active volcanoes, perpetually erupting. There are long extinct gigantic volcanoes on Mars, one as big as the British Isles. And beyond, in the dark outer depths of the solar system, volcanoes stir. It's only in the last 50 years that we have realized that Earth is not alone in its volcanism, that right across the solar system we see past and present volcanoes unleashing their incredible power. This video is about them. But to provide a benchmark, if you like, for our tour of the solar system's volcanoes, we're going to start right here on Earth, home to a huge variety of volcanic activity. Volcanic eruptions on Earth can take many different forms, each with its own unique characteristics. What are the most common forms? Plinian eruptions produce towering columns of ash and gas that can reach high into the stratosphere. A famous example of a Plinian eruption is the AD 79 eruption of Mount Vesuvius, which buried the Roman cities of Pompeii and Herculaneum under ash and volcanic debris. Another example is the catastrophic 1883 eruption of Krakatoa. Phreatic eruptions are steam-driven explosions that occur when magma suddenly and violently interacts with groundwater or surface water, creating huge amounts of steam. In 2019, 22 tourists lost their lives in a phreatic eruption on New Zealand's White Island, shown here. Effusive eruptions are gentler, with lava flows that build shield volcanoes over time. Hawaii and Iceland are examples of islands built solely by effusive volcanic eruptions. Named after the constantly erupting Italian volcano off the island of Sicily, Strombolian eruptions feature moderate explosions and lava fountains, often from small steep-sided volcanoes. Examples include Mount Etna in Sicily and Mount Erebus in Antarctica. Both regularly erupt in Strombolian eruptions. Let's move away from the Earth now to the Moon. Its surface is dominated by dark plains called mare, which consist of basalts formed 3 to 4 billion years ago through extensive volcanic activity. In addition to the mare basalts, the Apollo missions also discovered orange and green volcanic glass beads, remnants of the Moon's fiery past. However, the Moon's volcanic activity has been extinct for over 1 billion years, indicating a significant cooling and reduction in internal heat over time. These features provide important clues about the Moon's geological history and evolution, including its early period of intense volcanic and tectonic processes. Mercury's surface is dominated by ancient lava flows that cover around 40% of the planet. These smooth volcanic plains were formed by massive eruptions billions of years ago. Irregular depressions on the surface mark the sites where these volcanic eruptions occurred. Mercury's volcanic activity ceased around 3.5 billion years ago, and the planet has been geologically dormant since then. This makes Mercury a volcanic ghost, a planet with a volcanic past but no present-day activity. Venus is often referred to as Hell's Furnace due to its incredibly hostile environment, with surface temperatures reaching over 450 degrees Celsius and crushing atmospheric pressure. Mount Mons is the largest volcano on Venus, standing 8 kilometers tall. It's a massive shield volcano formed by highly fluid lava flows. Pancake domes are a unique type of volcanic feature found on Venus, created by the eruption of extremely viscous lava that spreads out into flat circular shapes. There's evidence that Venus has experienced volcanic eruptions within the past few decades, and indeed latest research says that there may be as many as 26 volcanoes on Venus active today. So what evidence do we have of current volcanic activity on Venus? Well, here are two radar images of Mount Mons taken by the Magellan orbiter in February and October 1991. In the February image, we see an almost circular volcanic vent. But by the time of the October image, the same vent has changed considerably in size and appearance, indicating an eruption has occurred. This is just one example of several similar instances where we can see changes to Venus' landscape which are difficult to attribute to anything but effusive eruptions. Moving out to Mars, Olympus Mons is the largest volcano in the solar system, standing at an impressive 25 kilometers in height. That's over 3 times taller than Mount Everest. The base of Olympus Mons spans an enormous 600 kilometers, roughly the size of the entire British Isles. This colossal volcano and smaller volcanoes across Mars' Tharsis Bulge has been dormant for an estimated 100 million years. Olympus Mons is a truly staggering geological feature, showcasing the immense scale and power of volcanism on the planet Mars. Io is the solar system's most volcanically active moon, with over 400 constantly erupting volcanoes. One such eruption is shown here in time-lapse images taken by NASA's New Horizons spacecraft when it was en route to Pluto. Jupiter's immense gravity squeezes and flexes Io's interior, generating intense tidal heating that powers this volcanic activity. The volcanic eruptions on Io often spew plumes of sulfur-rich material up to 500 kilometers into space, forming umbrella-like formations as they spread out. We can classify these as a sort of Plinian eruption, although different from Plinian eruptions on Earth because of the low gravity. They are also different because of their sheer scale. Such eruptions on Earth might eject just a few cubic miles of material compared to the hundreds of cubic miles of ejecta from a typical Plinian eruption on Io. Io is constantly resurfacing itself from effusive eruptions, which we know because of the lack of craters on Io's surface. These are similar to the eruptions on Hawaii or Iceland, but on a vaster scale. The length of volcanic eruptions on Io is linked to the Moon's orbit around Jupiter. They typically last weeks or occasionally months. All of this makes Io a truly unique and fascinating world in our solar system. Europa is another of Jupiter's Galilean moons, and it has a fascinating hidden world beneath its icy surface. The ice shell on Europa is 15 to 25 kilometers thick, a frozen crust covering a vast subsurface ocean that is over 100 kilometers deep. This ocean is thought to contain more water than all of Earth's oceans put together. Europa is a prime candidate for potential extraterrestrial life. Cracks and ridges in the ice shell suggest cryovolcanism, water plumes erupting through the crust from the subsurface ocean. Jupiter's powerful gravity causes tidal flexing of Europa's ice shell, generating heat energy that may drive this geological activity. Between 2014 and 2016, the Hubble Space Telescope imaged what are believed to be plumes erupting from these cryovolcanoes, although this has yet to be confirmed. But we may be able to confirm it soon. 2 spacecraft are currently en route to Europa in order to perform extensive studies of the Moon. NASA's Europa Clipper arriving in 2030 and the European Space Agency's Jupiter Icy Moons Explorer, or JUICE, arriving in 2031. Moving out to Saturn, Enceladus, one of Saturn's moons, is known for its dramatic geysers erupting from the South Pole. These geysers are fed by fractures or tiger stripes in the moon's icy surface, spewing water vapor and ice particles in another example of cryovolcanism in the outer solar system. Beneath the icy shell, Enceladus has a warm interior with, it is believed, a subsurface ocean like Europa's. On the floor of this ocean, we think there are hydrothermal vents, similar to the so-called black smokers found on Earth's ocean floor, for example at the Mid-Atlantic Ridge. The plumes from the geysers have been found to contain complex organic molecules, suggesting Enceladus may have the ingredients for life. Staying with the ringed planets, we now turn to Titan. Saturn's largest moon harbours one of the solar system's most intriguing mysteries. How does Titan maintain its dense nitrogen-rich atmosphere despite billions of years of atmospheric loss? Recent discoveries point to cryovolcanism, icy volcanoes erupting volatile compounds, as the key to understanding this enigmatic world's dynamic geology and potential for harbouring life. So what is the evidence for cryovolcanism on Titan? Firstly, NASA's Cassini spacecraft observed dramatic surface transformations in western Xanadu, an area of the Moon shown here in a radar map between its 2005 to 2006 flybys, revealing new dark features consistent with cryovolcanic eruptions of water, ammonia and methane. There's also the fact that Titan's atmosphere contains argon-40, a radioactive decay product from its rocky interior, providing compelling evidence of ongoing internal geological activity, releasing gases from deep within. And cryovolcanism offers the most plausible explanation for how Titan sustains its dense nitrogen-methane atmosphere despite low gravity and continuous methane depletion over geological timescales. The existence of cryovolcanism on Titan is important for understanding this dynamic world and its habitability potential. Titan's methane cycle mirrors Earth's water cycle, with liquid hydrocarbons flowing across the surface, pooling in vast lakes and evaporating into the thick atmosphere, a phenomenon unique in the solar system. Cryovolcanic activity could sustain this cycle by releasing fresh methane from a subsurface ocean, possibly enriched with salts and ammonia, creating chemical complexity that may support prebiotic chemistry. Understanding cryovolcanism is essential for NASA's Dragonfly mission arriving at Titan in 2034, which will explore the Moon's surface and subsurface ocean for clues about prebiotic chemistry and the potential for life. Titan stands as one of the most compelling destinations in the solar system to study exotic geology, organic chemistry, and the fundamental question of whether life can emerge in environments radically different from Earth. We now move out to Neptune. Its largest moon, Triton, is known for its remarkable geological features, including active cryovolcanoes discovered by Voyager 2 in 1989. These cryovolcanoes, also referred to as geysers, erupt volatile substances such as nitrogen, methane, and possibly water-ammonia mixtures. Voyager 2 revealed vast plumes rising up to 8 kilometers above the surface, driven by internal heat or seasonal solar warming beneath Triton's translucent nitrogen ice crust. These eruptions deposit dark material across the icy plains, creating streaks that trace prevailing winds and reveal ongoing surface renewal. Triton's retrograde orbit and likely origin as a captured Kuiper Belt object make this activity particularly intriguing, suggesting that tidal interactions and residual heat play an important role. Cryovolcanism on Triton provides valuable insight into how icy bodies can remain active far from the Sun, and it strengthens the case that similar processes may occur on other distant moons, with implications for subsurface chemistry and long-term habitability. And so we come at last to Pluto, surely one of the most enigmatic, puzzling, and strange worlds in the whole solar system. Before the flyby of New Horizons in 2015, we had no idea what this world looked like. It was expected to be frozen and lifeless, orbiting as it does on the edge of the Kuiper Belt, that dark, cold outer zone of our solar system. Instead, we found Pluto to be a dynamic, changing world with incredibly varied landscapes and geology. Glaciers on the move, mountains of pure water ice, jumbled rocky terrains, frozen plains, plus strong evidence of past cryovolcanism. New Horizons did not see any active cryovolcanoes, but we should remember that the spacecraft was only able to observe one hemisphere of Pluto as it flew by. The other was in darkness. So we've only really seen half of this amazing world, and it's not impossible there could have been active cryovolcanoes on the night side when New Horizons flew past. Pluto's suspected cryovolcanoes include Right Mons, shown here, a 90-mile wide and 2-mile high landform. Right Mons can reasonably be described as a cryovolcanic analogue of a shield volcano on the Earth, but not a shield volcano in the terrestrial sense. Right Mons is extremely broad, gently sloping, and low in profile, with a central depression reminiscent of a caldera. These traits closely parallel shield volcano morphology, which on Earth is produced by low-viscosity basaltic lava spreading laterally. On Pluto, however, the lava would be water-based ice mixed with volatiles such as ammonia, erupting at cryogenic temperatures. The physics, chemistry, and heat transport are fundamentally different. For this reason, scientists typically use phrases like shield-like cryovolcano rather than applying the term unqualified. Pluto is a world of mysteries. No further space missions are currently planned to return there to investigate those mysteries, so many of us will never see Pluto again in our lifetime. But New Horizons flyby emphasized something which has been a revelation during our exploration of the dark depths of the outer solar system, that worlds which logic dictated should be frozen and lifeless are not. They are dynamic, changing worlds with activity and energy. We have seen that there are volcanoes across the solar system as rich and varied as the worlds which birthed them. From the giant volcanoes on Mars to the fountains of Enceladus to the violently erupting geysers on Triton, we see volcanism right across the solar system. Some of it familiar, most of it not. But what are the engines driving all that volcanism? There are three main sources of heat which drive volcanism across the solar system. Firstly, the radioactive decay of elements like uranium, thorium and potassium has been generating heat within planets and moons for billions of years. This internal heat source is a fundamental driver of geological activity and the evolution of planetary bodies. Secondly, tidal heating from the gravitational pull of giant planets like Jupiter and Saturn can also create significant internal friction and warmth in moons and smaller bodies, as we see on worlds such as Io and Enceladus. And lastly, even after a planet forms, the residual heat left over from its initial creation continues to radiate outwards over time. These three key heat sources, radioactive decay, tidal heating and residual heat, are the engines that power the internal activity and dynamics of many worlds in our solar system. Well, we hope you've enjoyed this video about the volcanoes of the solar system. If you have, why not give it a like and leave a comment? Tell us which of the worlds we've discussed you find the most interesting. Also, support Space Oddities by subscribing to the channel and clicking the notification bell so you don't miss any of our videos. It only takes a second and is completely free. We have more than 600 videos on the channel dealing with all aspects of astronomy, astrophysics, cosmology and space exploration, which we hope you will enjoy browsing through. Thank you so much for watching. How can the moon have water? It's dry, it's dusty, it does not have weather, it has only the most tenuous of atmospheres. It's blazingly hot, it's numbingly cold. No clouds ever form above the moon, no rivers flow, no seas lap gently at lunar shores. 17th century astronomers gave the prominent dark areas on the moon the names of seas, like Mare Imbrium, the Sea of Rain. But they are not seas. They are plains of ancient lava, billions of years old. No soft spring rain will ever fall on Mare Imbrium. There's an ocean on the moon too, Oceanus Procellarum, the Sea of Storms. But no dark storm clouds will ever gather above it. So how could there ever be water on our beautiful natural satellite? One of the earliest proponents of the idea that there might be water on the moon was Harold Urey, a Nobel Prize-winning chemist who speculated in the 1950s and 1960s about the possibility of volatile compounds, including water ice, being trapped in cold regions of the moon. However, the concept became more concrete in 1961 when Kenneth Watson, Bruce Murray and Harrison Brown published a paper in the Journal of Geophysical Research suggesting that water molecules from cometary impacts or outgassing could migrate to and become trapped in permanently shadowed regions at the lunar poles. Between 1969 and 1972, the Apollo astronauts returned nearly 600 pounds of rock and soil from the moon. The samples underwent intense scrutiny from scientists around the world, a study which, nearly 60 years later, still progresses today. But no water was found in the lunar samples, confirming what scientists thought they knew, that the moon is completely dry. But then in 1976, the Soviet Luna 24 mission brought back soil samples with traces of hydroxyl, but this was largely overlooked. Hydroxyl, or OH to give it its chemical formula, is a molecule consisting of one oxygen atom and one hydrogen atom. It is not the same as water, but it is closely related. Hydroxyl can form when water molecules break apart or interact with minerals. In the context of the moon, it likely forms through interactions between the solar wind and oxygen in lunar minerals. It's a key indicator of water-related chemistry on the moon, even if it is not in liquid form. In 1994, NASA's Clementine mission detected reflections at the lunar poles, suggesting the possibility of ice deposits. Then in 1998, NASA's Lunar Prospector found hydrogen signatures near the poles, interpreted as potential water ice. However, the images returned from both spacecraft were of such low resolution that the discovery of water could not be confirmed. This picture is a later image of the Moon's south pole by NASA's Lunar Reconnaissance Orbiter, the water marked in blue. But then, in 2008, reanalysis of Apollo samples by Brown University scientists found both hydroxyl and water molecules. It seemed that initial analysis of the Apollo moon rocks had overlooked them due to the inadequate analytic technology of the time. Then, in 2009, India launched their Chandrayaan-1 spacecraft to the Moon. Mapping the Moon's surface with an X-ray spectrometer, the spacecraft created maps of mineral deposits. But it also released a small impactor, which, striking the Moon's surface, also detected both hydroxyl and water molecules. NASA's LCROSS mission, launched in 2009, aimed to confirm the presence of water ice in permanently shadowed lunar craters. The mission targeted the Cabeus crater near the Moon's south pole, where previous data suggested potential ice deposits. LCROSS deliberately crashed its Centaur rocket stage into the crater at high speed, creating a debris plume. The LCROSS spacecraft, following closely behind, analysed the ejector before it too impacted the surface. The debris plume was also analysed by NASA's Lunar Reconnaissance Orbiter, or LRO. Instruments detected water ice along with other volatiles, confirming that significant amounts of frozen water exist in these shadowed regions. This discovery was a major milestone, strengthening the case for future lunar exploration and resource utilization, including human missions and potential in situ resource use. LCROSS provided concrete evidence that the Moon holds accessible water, which could be critical for sustaining long-term lunar bases. There may be more than 1 billion tons of water ice locked up in the permanently dark craters at the Moon's poles, where the temperature is a constant minus 230 degrees Celsius. So where did it all come from? Water-rich comets and asteroids bombarded the Moon in its early history, particularly in a period about 3.5 billion years ago known as the Late Heavy Bombardment, depositing ice that became trapped in permanently shadowed craters. It may also have come from hydrogen in the Sun's solar wind reacting with oxygen in lunar minerals to form hydroxyl and small amounts of water. There were also ancient lunar volcanic eruptions which released water vapour, some of which could have migrated to the poles and become trapped in cold regions. And the Moon is constantly being bombarded with small meteoroids containing hydrated minerals, delivering water molecules to the Moon over time. That water ice can be used by future human bases on the Moon. It could be used to extract the oxygen from the ice for breathing, further processed to produce rocket fuel, be used for radiation shielding, agriculture, hydroponics, thermal regulation, industry and many other applications. All we need to do is to find the ice and figure out an extraction and transportation system, but there is no doubt that the ice is there in large amounts. In 2023, India's Chandrayaan-3 spacecraft landed at the south pole of the Moon to search for water, but only detected hydrogen and oxygen separately, not as H2O. The US and Russia have also launched spacecraft to find the water, but so far their missions have failed. However, the US, Russia, China, India and Japan are all sending missions to the lunar south pole to search for the water over the next couple of years, so it's likely that at least one of those countries will find the water and eventually construct a base at the south pole of the Moon. It's taken 70 years since the first suggestions that there might be water on the Moon, but at last it looks as though we may find it, and use it for the advancement of human lunar exploration. And there you have the story of water on the moon. Thank you for watching, and I hope you'll watch the other videos in the Space Oddities Moon Month series. Check out the Moon Month playlist on the Space Oddities channel.
Okay. Now I still can't hear you. Can you hear me? I'm not hearing anything. Okay. So is this me? No. Are you hearing me, Andy? Just give me a thumbs up if you're hearing me. I'm not okay. All right. I'm not hearing you. So, but my volume is up.
Okay, try that.
Oh, there we go. Okay.
Yeah.
Yeah. All right.
Thank you, Sandra. I had put that on mute. Sorry, Dave. That was my fault.
Okay.
So, yes. So take 2 tonight, the second attempt at launching the Starship. As you may be aware, if you were with us last night or you've seen it in the press, yesterday's attempt to launch the Starship was aborted at 40 seconds before liftoff, because there was a pin which holds the tower arm in place before launch, holds it against the rocket, and that pin is meant to retract so the tower arm can swing out of the way, and the pin didn't retract. So yes, we thought yesterday it was to do with the fact the water deluge system didn't fire up, but not only did the pin not retract, they had anomalous temperature readings on the fuel. So anyway, I'm sure these are minor things that they've fixed today. Well, they must have fixed them, otherwise they wouldn't be.
Well, the pin sounds minor. I hope the temperature thing isn't.
Yes, the temperature thing is a bit more worrying. But anyway, if they weren't confident that they've solved it, they wouldn't be trying to launch again tonight. So so there we are. Okay. Now, if you weren't with us last night, we were talking last night about the changes to the Starship. This is a completely new vehicle, redesigned from scratch. Both the booster and the Starship itself have been completely redesigned. This is the new Block 3 Starship, the new generation of Starship. And there have been quite a few changes. So just give me 1 second. And what I'd like to do is to go through some of these changes with you. Apologies if you were watching last night, you've got to sit through it again. But for the benefit of those who might not have been watching last night, let's have a look at the changes to, first of all, the Super Heavy booster. This one is B19 or Booster 19. Going from the top, the hot staging ring is now an integral part of the booster. In the past, it was detachable, and it used to detach from the booster after the Starship is separated, but that's now built into the booster and has been redesigned aerodynamically. So we've got an upgraded hot staging ring. The upper section has been reinforced to give it more strength. This is to handle the incredible rage, if you like, of the Raptor engines from the Starship as the Starship separates from the booster during the hot staging process. The hot staging process basically means that the Starship fires its engines seconds before separating from the booster to basically develop more thrust. Going down, there's a completely redesigned propulsion system. We've got our 33 Raptor engines developing more thrust than the Saturn V and the NASA SLS put together, which is an incredible amount of force. Larger fuel capacity, enhanced thermal protection. The bottom of the rocket used to have each engine separated by its own heat shield and protection system. That's no longer needed with increased reliability. So they've managed to shed a lot of weight there with a new enhanced thermal protection. And the whole booster has been built for rapid reuse. If we move on to the Starship itself, completely new heat shield, more durable tiles that shouldn't fall off as they always used to in quite large numbers with earlier models of the Starship, designed for faster turnaround and higher reusability. Upgraded forward flaps, new forward flaps that have been moved slightly round of the fuselage of the Starship, again with better thermal protection to stop them melting on the way down, as they did with earlier Starship tests. Bigger aft flaps, 20% larger to provide greater aerodynamic control as the Starship is coming down through the atmosphere. 3 sea level Raptors, 3 vacuum Raptors for use in space, a new heat shield at the bottom, and the whole thing again is built for rapid turnaround and reliability. Now let's have a look at what we've actually got coming up tonight. This is the flight plan for tonight. So if all goes well, at 11:30 UK, the vehicle will launch. The booster will then separate and return. Now, they're not going to try catching the booster with the tower arms, the famous chopsticks, which people said would never work, but have worked every time they've tried it. NASA didn't want to risk the brand new launch tower with the new vehicle, just in case. So today the booster will be splashing down in the Gulf of Mexico instead of being caught by the tower. After separation, after main engine cutoff, the Starship will ascend to its apogee. It's not going into orbit. It's following a parabolic flight, which will return it to the Earth. At the top of that, at the apogee, the highest point, it's going to release 22 Starlink simulated satellites. These are not real Starlink satellites, but they have the same dimensions and mass as the real thing. Again, NASA didn't want to risk losing 22 satellites on the first flight of a brand new vehicle. 2 of these satellites are called inspector satellites, whereas the others will just fall into the atmosphere and burn up. These 2 will actually hang around the Starship, photographing the heat shield from close up at high resolution, so engineers can inspect how the heat shield survived the ascent of the vehicle. Once payload deployment continues, the so-called PES dispenser, the mechanism which actually pushes the satellites out of the Starship, has been redesigned as well to push them out faster. So we can't wait to see that in action. The Starship will then descend through the atmosphere, go through its re-entry phase, and then splash down in the Indian Ocean west of Australia. And just a heads up, coming up possibly in June, although it has yet to be confirmed, but it looks likely that in June, SpaceX will attempt an in-orbit Starship refueling operation. First time ever done in space, transferring fuel between 2 vehicles. This refueling is needed for NASA's Project Artemis to return humans to the moon, because a lunar version of the Starship will be the vehicle that lands people on the moon with Artemis 4 in late 2028. And it's going to need refueling before it can leave Earth orbit for the moon. So they need to get this refueling operation under wraps before that, with lots of practice. So this will be the first time this has ever been done. And they've got a really clever guidance system to guide the Starships autonomously next to each other, as you see in this image, with centimeter accuracy. And as you can see, you've got refueling probes that go into receptacles on the other Starship, the one being refueled, to transfer hundreds of tons of fuel across. So as I said, it has not been confirmed yet, but it looks likely that it will happen. SpaceX needs to start this soon in readiness for Artemis 3, which is the flight to practice docking between the lunar Starship and the Orion capsule, the Artemis Orion capsule. And that's due to happen sometime next year. probably towards the end of the year again. So they need to get this refueling under wraps, and they've got until next year to do it. So although there's plenty of time, they've still got a lot of work to do. The idea is that they will fully fuel a Starship, put it into orbit, and that will act as a sort of a fuel depot. And then a couple of weeks later, they will launch another Starship to dock with it, which will be refueled from that fuel depot. So lots of exciting stuff coming up. And of course, on Space Oddities, we will bring you it in its entirety when it happens. So there we are. That's what we've got. That's what we've got on the agenda for tonight. So just like to say,
Oops.
good evening to Daz, who I think. Okay, there we are. So Roger's joined us this evening as well. How are you, Roger? Can't hear you.
I'm on mute. Whoops. I thought I'd make up from Michael and Lou tonight.
Oh, yes. Lou can't join us this evening because he's gone to see an opera. And Michael can't join us because he's lazy. So, so you'll start with us for this evening, I think, unless Tom turns up. Tom's a bit like the Scarlet Pimpernel. We never know when he's going to turn up next. But Tom, if you're watching, come and join us. We'd love to see you here. So, guys, well, we have to do it all again. Go through it all again.
Yeah, we certainly have. Do you want me to put the?
Yes, you could. If you could patch in NASA Space.
I've actually succumbed to going premium, so we shouldn't get any adverts.
Oh right, have you?
Yeah.
So you're the person that plays for YouTube Premium.
The sacrifices I make.
Okay, great, thank you. Yeah, if you could patch us into NASA spaceflight, that would be great.
Yeah.
And we'll go over
just
to.
Bear with me.
We'll go over to Starbase and see what's going on. Propellant load has started, and let's see what's going on.
Do you want to listen to the sound?
Yes, let's have a listen into NASA spaceflight to see what they're saying.
Can you hear that?
The video's not actually running. No.
The Saturn V launch pads back in the 1960s. This is going to be a really beautiful sight, isn't it?
I'm so excited. I don't think anyone on this stream is not. We've all been waiting for this for so long. It feels like, 7 months since we last seen a spaceship in action. This version 3 is going to be something else to see, and what a marvel we're all looking at. I think we're looking at the response now about what they did with the pin. Alex, do you want to give us an update of what kind of information we're getting from the SpaceX team about what they did to fix that pin issue from yesterday?
They tried to solve it, basically trying to adjust the arm, where the pin is located and whatnot. I'm gonna be honest, I completely missed the very specifics of the explanation, but it nailed down to just basically trying to adjust how the pin retracts and changing some of the software as well on how that works so that it doesn't get jammed at the time of retraction. And yeah, that happens after that T-minus 40-second point in the countdown, where, ahead of retracting that arm at T0, they do that unlatch, sort of like, if you were to unlock your door sort of thing, and then you pull the handle and that sort of thing and try to open, that happens at T0. The unlocking happens a few seconds before that, after that T-minus 40-second point.
And Sawyer, now we're through that kind of T-minus 20-minute mark. Of course, as you said, no T-minus 20-minute vent from Starship like we see from Falcon 9. But from now on, pretty much until 2 minutes to go, we're just going to sit back and not relax because we are full of adrenaline, but it's just propellant load from here on out.
Yeah, pretty much. At this point, it is a large vehicle, as we've talked about, and they have a lot of propellant to load, so it is loading it up at this point. but it is much faster than it used to be. I mean, we thought it was fast originally with the earlier versions where it was under an hour to load the vehicle. The fact that now it's under 40 minutes to load the vehicle is still something that boggles my mind, no matter how many times I mention it on stream or mention it at all. So, yeah, at this point we wait for the prop load, and there's not much else we can do, which that's the hardest part now is the waiting, as Tom Petty once said.
This camera is in the dunes, as you can tell, super wide lens, and we haven't cropped it on purpose. That is some protection in front of the camera to try and prevent anything going into the camera that shouldn't be there. I think you can fill in the gaps there as to why that camera has that extra shielding. Just like, you know, the ship has thermal shielding, our cameras have physical shielding. Kinetic shielding? I don't know. There we go. We have some experience with that. Moving on, 18 minutes, 15 seconds left to go. And again, the heart rate continues to rise. There's still a lot of birds flying around the area. The wildlife certainly are taking an interest as to what is happening right now. I'm not sure they'll be so interested when they light the engines and take off. They might quickly vacate the premises, but we'll just have to wait and see what happens there. Fingers crossed they don't get in the way of any of our camera views.
Yeah, and a reminder for that view, these are pretty zoomed in, so it's not like the bird is flying directly next to the rocket, like the rocket's going to fly into it. These birds are a lot farther away. Birds in camera are closer than they appear, or farther than they appear.
Okay, you can kill
Thank you, Sawyer. I'm also just seeing now some confirmation. It looks like the...
Okay, so, well, we've got... 17 minutes left before the launch. Viewers, of course, if you have any questions, anything you want to know, please put them in the chat and we will do our very best to answer. So who have we got with us this evening? Hi, Sandra. Hope you're well. Ian's here. Heidi's here. Nice to see you all. And who else we got here? Nobody admitting to being here at the moment apart from that. So if you're new here, please introduce yourself in the comments. Just tell us your name and where you are, basically, because we love to know where people are watching us from. So, guys, well, I guess it's the same as last night, really, isn't it? I think if I ask the question, what are we looking forward to? I think the answer will obviously be getting off the ground this time.
Yeah, and getting off the ground on time, which I think is probably even more important to you guys since it's already late there.
Absolutely.
Oh, we'll sit here all night. We don't care as long as we see a launch. Yes, I mean, yesterday they tried at least 3 times, and it was right at the end of the count. So, which is just basically they were milking it. They were teasing us. But yeah, it was. I mean, we were there. The heart was going. You know, you're on tender hooks. You're there. Oh, go on, go. Oh,
yeah.
Oh, oh, here we go. Oh.
How many times did they put that countdown back to 40 seconds?
That's right. It was about 3 or 4 times, wasn't it?
Yeah.
And then they said, we're going to scrap.
Back. And then they said, no, not going to happen.
Yeah.
So there you are. I mean, one thing about this whole thing, you know, we should remember that this is still a test vehicle. And not only that, this is a brand new version of a test vehicle. So, you know, we can't expect SpaceX to, although it would be nice, we can't expect SpaceX to get it right first time because this is an immensely complicated machine, the most powerful, complicated rocket ever built in the history of rocketry. And it's just the most amazing creation from SpaceX, which they have developed in record time. No other space agency or company has ever developed a vehicle of this complexity and magnificence so quickly, because as we were saying yesterday, it's only a few years since they launched the Starhopper to test the first Raptor engine, and that went up to only about 500 meters, if I remember correctly, and came down again. And now, just a few years later, look at this. It's the progress that they've made in such a short time has been unprecedented. So, you know, I guess when you're employing the most brilliant brains in the business, this is what we end up with. And the vision behind the Starship is that this is the vehicle that will allow us to explore the solar system. It can carry a lot of cargo, up to about 150 tons with this version of Starship. And for setting up bases on the Moon and Mars, this is the capacity that you need. You know, this could be the vehicle that takes us to Mars and to the outer planets eventually. But you know, we'll have to wait and see. This is built around traditional rocket engines.
Yeah.
With liquid methane as the fuel and liquid oxygen as the propellant. But there's a lot of research going on into nuclear electric propulsion and nuclear thermal propulsion to develop rockets that can get us into the solar system a lot faster. This may not be the last word in propulsion methods, but for the moment, it's the best we've got. It's going to be.
I mean, rockets this size had to come at some time, so why not now? But like I say, if you could put a nuclear engine or or some sort of thrust, completely different thrust mechanism in it, you know, you imagine this with a sort of a nuclear engine. It would take us anywhere in the solar.
It'll be tried. Yep.
Yeah,
I'm
well,
sure it will be tried.
Oh, it will be eventually. I mean, it's got to happen sometime. And like I said, why not now? We need rockets this big for our ambition to be able to move on and start, you know, putting bases here, there, and everywhere. So why not now? And we're just lucky enough to be sat here, watching these giant rockets, you know, take off. It's absolutely fantastic.
We've got a comment here from Leon, who is in the West Midlands in the UK. Good evening, Leon here, watching from the West Midlands, trusting you guys to explain what's going on. That may be your first mistake.
Yeah, well, that big mistake.
No, only joking. We will.
Whereabouts in the West Midlands are you, Leon? Because I'm in
Where in
Shrewsbury,
the West Midlands
on
are
the
you?
Welsh borders.
Tell us where you are exactly, just out of interest, because Daz is not too far away. So Dave's in the States, Roger's in Sparkford, in the deepest, most depraved depths of the West Country, and I'm in Spain. So so there we are.
Roger's where they still burn witches.
Yeah. But only on Sundays.
Oh, right.
So there we are. So how long we got to go now? 11 minutes to go.
We've got some nice frost lines forming on both the booster and Starship.
We've got some nice. Let's just magnify this a little so we can see a little better what's going on. Okay, so that tank farm furiously in action now.
Yeah, it looks very different from yesterday. The the exhaust, I guess, the condensation was going a lot higher, and now it seems to be hugging along the ground. I guess it's just different temperature structure there in the atmosphere,
weather
or something.
conditions in that.
Less wind probably as well. So although it looks quite breezy there, looking at the
and also it looks a bit duller, doesn't it, than it was yesterday? We had some lovely clear skies yesterday, but there's a bit of a grey haze, but nothing to worry about by the sounds of it. So
so countdown is progressing. We're now just over 10 minutes to go. Beautiful sight. Oh, that looks very sunny there from that angle.
Yeah, I think it's the way the sun's, the brighter lights catching the plumes. But of course, we can't see the rocket.
And Ian says, "No, I'm where they burn, which is Inverness." Yeah, that's
right. Okay.
Yeah.
Well, I'm just outside of Washington, D.C., where apparently we have witch hunts all the time. At least that's what I hear.
Right.
I'm in Sandwich, and Michael, who's missing from the panel tonight. Well, Michael is missing because of other engagements. Lou in the States is missing because he's gone to see an opera. Tom in Scotland, well, we don't know where he is, but
probably burning witches.
Yeah. we do have other members. We have somebody in Canada who we haven't seen for a long time. Kareem.
No.
Must inquire how he is. Haven't heard from him for ages, but he is still technically a member of Space Oddities. So there we are. So what are you doing in Washington, Dave? You get about a bit, don't you?
Oh no, I live just in Maryland, just outside of Washington.
Oh, Maryland, right?
I mean,
right. Sorry,
yeah.
You must forgive our pathetic British geography.
No, yeah. Right. Look, when I first saw Midlands, I thought it was Texas. So what can I say?
This is the original Midlands.
There is a Midlands in Texas too, and so I thought maybe Leon was a Texan.
Yeah. Yeah. So what we're looking at now are just the final stages of propellant load on both vehicles. As you can see, the frost line is building up there. The white line, see it very clearly on the booster there at the bottom. That's that frost that accumulates because the cryogenic fuels, of course, are incredibly cold, and the Starship as well, all going well, and nothing much to say at the moment apart from that. At just a few seconds before the launch, we will first of all see the detonation suppression system. This is basically a spray of nitrogen that you will see underneath the vehicle. That is to waft away any residual potentially explosive gases underneath the rocket. After that fires, you will see the water deluge system, this countless thousands of gallons of water being sprayed onto the launch pad. And then at T0, you will see the 33, the unbelievable force of the 33 Raptor engines in the booster firing into the new flame trench. So you will see the exhaust exiting on either side of the launch pad. This is brand new. Happy to report that after the static fire they did of the engines last week, it looked completely unscathed. So it looks like that's going to be a good design. Because, of course, with previous Starship flights, we've seen the launch pad turn into a disaster area after the launch, and so they've got that under control, and then the Starship will lift off. You will see it veer slightly away from the tower as it ascends to avoid crashing into the tower. It's a safety thing just in case, but only by a couple of degrees it will veer away, and then we will see what happens with the flight. We will see the booster separate from the rocket, and then the Starship carry on towards space. The booster will return, as I said earlier, not being caught by the arms on the tower this time, the famous chopstick arms, because SpaceX didn't want to risk their brand new launch tower with a new vehicle and lose both. So the booster will splash down in the Gulf of Mexico, just a couple of miles offshore. So, and then the Starship will ascend to orbit, release 22 Starlink simulator satellites, and then return to splash down in the Indian Ocean west of Australia at the end of its flight. So that's what we've got ahead of us. We are now just under 6 minutes before launch, and there's Jared Isaacman, NASA administrator, chatting to
yeah, I think there was a cunning plan yesterday because he didn't actually attend.
No.
And I thought he's not there, and now he's
That's
there.
right,
So I think we stand a better chance of actually seeing it launch.
Yeah.
Or there'll be questions to be answered.
Yeah.
He had a
just to answer Ian, it's actually Washington D.C. Just outside of Washington D.C. But Barry said West Coast. I'm actually flying to the West Coast tomorrow, so I'm spending half my time on the West Coast and half my time in the East Coast. Just just to eliminate the confusion. Anyway.
Yeah. So you can see the venting on the rocket. This is expelling excess fuel. They have to keep the levels of the fuel tanks, the fuel tank and the liquid oxygen tank topped up because it boils off rather quickly. Here we can see an animation of the lunar Starship around the moon. The lunar Starship is under construction by SpaceX. We've not seen any official photos yet, although we have seen mock-ups of what the interior will look like. But SpaceX are keeping the lunar Starship well under wraps at the moment. It looks like the Starship that you see there, but it doesn't have any fins because it will be operating in a vacuum. It does, and will not land back on the Earth, so it doesn't need any fins. And it's going to be an amazing vehicle, and 150 feet tall, which they're planning to land on the moon with some little eggs. And we just hope that they find a flat enough area on the moon to land that. But I trust they know what they're doing. So, as I said, we haven't seen the lunar Starship yet. Can't be too long now until they unveil it. But there we are. Okay, for the last 3.5 minutes, should we listen into the commentary, Daz?
Just bear with me.
Certainly. Thank you all so much for being here. It's
40
great to have
seconds
you,
actually
you
for the
watching.
booster propellant load complete part of the sequence here, and then about 40 seconds after that it'll be the ship propellant load complete sequence of the countdown. But yeah, everything's still looking good, so hopefully we go through all that T-minus 40-second point.
Indeed. Alice, do you have any final kind of thoughts on what we will, fingers crossed, see in 3 minutes from now?
Light this candle. I feel like this is going to happen. I don't know what it is about today, but today feels definitely far more exciting, far more ready for it. I feel like this is going to breeze through, and yesterday is going to be a distant memory. They're going to do it, and things are going to go to plan. I've got a very positive feeling about this.
Same question to you, Sawyer. What's going through your mind right now?
They're going to do it. It's SpaceX. They're actually going to do it this time. We'll see if they hold at T-minus 40 seconds again. They have the option to, as a reminder. They don't have to, but they can if they choose to, and they can hold for about 10 minutes. Let's hope we don't need that. Let's hope we just see this thing rise off the pad and have a successful flight.
And look at that. They're basically 97%, if you round all of the tanks, fueled on both booster and ship right now. Almost full on ship, almost full on booster. That is great news indeed. I have to say, I hope SpaceX will be go for launch. I know everybody here is go for launch. Chat, are you go for launch? We need to know if you guys are go for launch, because if chat isn't go for launch, then, I don't know, maybe someone needs to phone up SpaceX and let them know that chat needs a minute to get ready. Okay, no, chat's ready. Chat's very ready. Chat, yes, lots of goes in chat right now. Everybody is very, very excited to see this thing fly. And yeah, we are excited with you. We are 1 minute and 40 seconds away from Starship Flight 12.
Go. Ship propellant load complete by the looks of that. Seems like the purges on the launch mount are underway. They're currently doing gimbal checks on the booster engines. There we can see
And we can
those.
see that.
That's the
There they are.
Oh, yeah.
dancing.
Look at the gimbal.
The inner 13 steering there.
Yeah.
Those are those gimbaling Raptors. Of course, the outer engines do not swivel, only the inner ones do, because they have, as you can see there, very helpful from this launch mount camera, they have that extra clearance there as we approach 60 seconds until launch. As a reminder, SpaceX has a gate at 40 seconds. If they need to hold, they can. But fingers crossed they have resolved the problems and they are able to push straight through that gate, which will be coming up in a few seconds' time. Of course, if they do have to hold, there'll be a little bit of a delay before we hear that. But fingers crossed, everything is good to go for launch in 45 seconds from now.
They push through
I
it.
had a good feeling about that.
Let's see, are we continuing to push through?
Let's hold.
And we have a hold.
Just say.
Oh.
Yeah.
Oh, sorry. Said
Once
that.
again,
Shouldn't have said that.
once again, waiting for the pushbacks. So it might be reset really quickly here. Just like yesterday, remember? I heard the vent and the clock is rolling.
There we go. Clock is running for launch.
Wow.
Stand by
Okay.
for the detonation
My director
suppression
is go for
system.
launch.
That's what we want to hear. SpaceX are go for launch. We're going to stand by for the deluge. That'll be a really obvious thing. And then, of course, that ignition and top deck going off. Starship V3 might be about to fly.
Oh,
There's
there
the
we
wheel
go.
vent. There comes the deluge. Let's look. There's the top deck. We should be
Yes.
seeing ignition.
Wow.
Oh, there we
There's
go.
ignition.
Yay!
Yay!
And I believe we have liftoff of Starship version 3.
It's
About
done.
bloody time.
Yes.
There it goes.
It's done.
Wow.
Oh, wow.
Look at that.
20 seconds.
It's not hanging about.
No, once it gets some revs up, looks like all the engines are
10
like
seconds
it.
max.
Yep, definitely.
Starship version 3 is airborne, and we are headed to space under the power of 33 Raptor 3 engines. We are pushing
looks-
through max Q. Oh
pretty good.
my goodness. This is the period of maximum force on the vehicle when the thrust meets the thicker parts of the atmosphere. But there we go, we're pushing through, and it looks like we're getting a little bit of a vapor cone even forming there as the trail falls away from Starship. This is a spectacular ascent of Starship version 3. That looks like a flawless liftoff, passing the moon
you
in the
kidding me?
background.
That was so
Kidding
cool.
me?
We will be going there eventually with Starship, but for now it's a suborbital test flight, the future destination in the background. For now, the destination is the Indian Ocean, and Starship continues to progress downrange.
Oh,
We
I
are
love that
passing
picture.
through 23 kilometers in altitude, and we have healthy Raptor 3 engines on booster 19. We're a few seconds away from main engine cutoff.
One engine off on the outer ring of 20.
Okay, we've lost one Raptor 3.
20 seconds. Miko.
32 of 33.
Yep, looks
But
like now
that's-
they're rolling for preparation for hot staging.
That's still the vast majority of engines. We'll have to see how many of those can relight for the boost back burn of Booster 19. But for now, Ship 39 and Booster 19 doing a spectacular job. Let's stand by for stage separation.
Hopefully we see that hot staging.
Oh,
There is.
There is ship engine ignition. And we have stage separation. What a quick flip!
What a
The
flip.
booster is already facing the opposite
Oh
direction.
boy.
That was an expedited flip and a half. Oh, maybe the booster is losing a little bit control, or can it correct? Looks like a little bit maybe of an over-energetic spin from the booster. Looks like it can correct. It looks like it has the authority to correct.
It's
Seeing
only
a little bit of a
5
flash from the
engines
aft.
on
Oh
and
dear, only
shutdown
5
of the
engines.
booster. Yeah.
30 seconds.
Were those the
pushback
5
burn.
All
pusher
6
engines?
engines on the ship, though.
Good news from the ship, but that looked like a little bit of a wonky boost back burn from the
20
booster.
seconds. Boost back shutdown.
It's a yeah, it aborted the boost back burn.
Okay. Again, today is a test
one,
flight.
One Raptor
Boost back
vacuum is
shutdown.
off on the ship.
We lost a Raptor vacuum.
Oh, no.
So
Okay,
5 more.
we are currently running on 2 vacuum Raptors and those 3 sea level Raptors. And you can see there, I believe, on the left-hand side, that is the booster losing control. And you can see there from the ground, this is the Super Heavy Booster 19 with an aborted boost back burn. That will fall down. I think that's the ship in the background. You can see the booster falling back down to the Gulf
might
below.
be.
And the ship is burning in the background on 5
Yes.
Raptor engines, 2 vacuums, 3 sea levels. One of the vacuums has shut down early, but the other 5, Alex, they seem to be continue firing.
Yes.
Do you think they could get
And-
on their
and they-
trajectory with a subset of engines?
They mentioned that they have engine out capability, so the ship will just be burning a little bit longer, basically, to compensate. But yeah, one of the Raptor vacuum engines went out. It has the sea level still running, so those can compensate both on the gimbaling for attitude control, and also the fact that they can run for longer with those 3 engines, plus the other 2 Raptor vacuum engines. Still accelerating, speed still going up on the ship. The booster is stumbling a little bit as it comes back through. It did
We are
not complete
watching
that
the
boost back
booster
burn.
from the off-board tracking views. We are watching it from the ground. So a little bit of a wonky boost back burn, an aborted boost back burn from Booster 19, and it is now tumbling and falling back down towards the Gulf. Again, we were not expecting to recover this booster at all on this flight. SpaceX were hoping for a good boost back and a splashdown in the Gulf. Looks like it's going to be a bit more of an energetic splashdown than they perhaps were initially expecting, but that was a very, very quick flip from the booster. I mean, that was absolutely bonkers to see live on screen in front of us. In the meantime, Ship 39 continuing to burn towards space. case. It has lost a Raptor vacuum engine, but as Alex said, they have Raptor out capabilities. They are continuing to burn. The other 5 Raptors seem to be continuing as normal, and the ship is continuing to pick up speed as we push towards 9,000 kilometers per hour. So fingers crossed, Ship 39 can make it, even on a reduced subset of engines, because of course they only need the 3 sea levels when it comes to do their Raptor relight demonstration, which they could cancel if they need to, and their splashdown burn for landing in the Indian Ocean. So stay fingers crossed for the ship. And yeah, we can see there now, Alex, the booster picking up speed.
Look at that entry. Wow.
Yeah. This is toasty.
Yeah,
this is...
Oh yeah. The roll's picking up a bit, it looks like, too. We'll see if they end up actually trying for the landing burn for the booster there.
I think we might be going a little bit too quickly at this point. We are now going through 7 kilometers.
Yeah.
It's literally horizontal. We are going to be on board with the booster until the very end, I think, as we pass through the clouds on board Booster 19. Look.
Testing at least the grid fins. Oh,
yeah,
it's
a vapor
relighting
cone.
the engines?
We've got an ignition. They're going for a landing burn.
Wow.
It was an aborted boost back burn, but they're going for a landing burn.
Oh,
the booster has ignited. Frozen cameras.
There we go.
It looks like an impact in the ocean.
Yeah.
But in the meantime, we go back to space, back on board Ship 39, passing through 12,000 kilometers per hour in speed, through 6.5 minutes into flight, and 5 Raptors continuing to burn. We have lost one of those Raptor vacuums, but the other 5 engines continue to burn. So fingers crossed, should this continue in this configuration, Ship, with its authority of the 3 gimbling Raptor engines, should be able to make it onto that trajectory. And that was a very spicy booster flight indeed. Okay, we're getting the gadgets now to show us the exact orientation of the ship. It looks stable, Alex. It looks stable.
It does. It lost that RVAC engine, but again, it's got engine out capability. So the rest of the engines, the 5 remaining engines, will just burn for a little longer. I would expect the other 2 RVAC engines to shut down as planned closer to that final shutdown. If you remember, they used to shut down the engines first, the RVACs, and then the center engines.
Yep.
Oh,
by the way,
on board in the engine bay coming up, there it is.
Wow,
Something's glowing.
By the way,
I'm not sure.
That timeline you see on the bottom, obviously it's a little off because it had the super landing booster later, so it may be still burning when the bottom thing says Seco.
Exactly. Don't be surprised if those are a little off. But as you can see there, those are 3 sea-level Raptor plumes and are glowing in the aft bay of Ship 39 indeed. But at least the engine is still there. It doesn't look like the engine exploded or caused any debris. It's still there, intact. Maybe just a premature shutdown, so maybe a sensor or something. We'll have to wait and see what SpaceX says when they do their data reviews. But for now, Ship 39 continuing to burn. Again, don't be surprised when we push through this Seco mark. Initially, this was expected with 6 engines. We have lost one of those engines with only 5 burning right now.
At what point were they supposed to release the satellites?
I mean, look at that camera angle. Is that not just absolutely stunning?
The sunset views are beautiful.
Sorry,
I love
Dave, what
these
did you
evening
say?
launches.
I said, can you drop the volume levels?
Looks like the Raptors do continue.
I was asking when they were. At what time are they planning to release the satellites? It must be pretty soon, right?
Have a look.
Yeah, Daz will tell you. He's got the data there.
Oh, okay. Thanks, Daz. It's a suborbital flight. It's not.
Right.
A lot of time, I guess.
It was due to be done 17 minutes and 37 seconds into the flight.
Okay, thanks.
So we've still got a bit of a way to go.
Right.
What are your reactions, guys?
Well, it's a little bit disappointing about the booster, but it's all data. The launch was virtually perfect, except for the one Raptor going off.
Yeah.
But
I mean, I think the key is this. Okay. Something's happening.
The sea level Raptors shutting down. And the vacuum Raptors lighting. Yeah, it was. The speed at which that booster flipped over was just unreal. An object the size of a skyscraper flipping over like that.
Yes, that's true.
It was just unreal. And
They're cheering about something.
yeah,
Yeah,
so
that was a spectacular view
look at that. Oh,
of
look
the
at that.
flat Earth. I
Yeah.
guess.
Yeah. Yeah. No, they were very happy, bless them. Of course they are. They've done a great job. So Starship still fully under control. You know, we have seen at this point in the flight, or maybe a bit later in previous flights, the Starship start to lose control and the Earth start to spin wildly in the background.
That's beautiful images, though.
Yeah. Absolutely. I presume they're testing the flaps.
Yes.
I've got to go through lots of tests on this mission.
Yeah, everything. Like I say, as we said at the very beginning, this is literally they've gone back to scratch.
Yeah.
This is a brand new ship, so it's almost as if it's the first time they've done it. There's been so many changes.
Can you see my mouse pointer at the moment?
No.
Sorry?
No. Right. If you look towards the top of the vehicle, there's a sort of a conical thing there.
Oh, right.
That is one of the refueling ports.
Oh, okay. Okay.
It is now built into the Starship for orbital refueling. The fuel probe will probe that from the other Starship and transfer the fuel into the ports. And as I said, we believe unless SpaceX want to do a repeat of this to get things right before they tackle orbital refueling, but the strong rumor is that they will attempt the first orbital refueling next month. So we have got that to look forward to. In the meantime, look at these glorious views of our planet. It's just
it only is.
And this is 4K video coming via Starlink satellites. They found that when the Starship re-enters, you see traditionally with spacecraft, if you think back to say Apollo or Gemini or Mercury, they would go through a period upon re-entry of losing communication because the spacecraft couldn't transmit through the plasma that was surrounding it. But with the Starship, because of its shape, there is actually a narrow gap towards the rear of the vehicle in the plasma that they can transmit through.
Oh, wow. Okay.
And because of its aerodynamics, you have to ask an expert to explain that better. But basically, that allows them to keep in touch with the Starlink satellites to relay the images back to the Earth. So
it looks like the ship's reorientating itself for dispensing of the dummy satellites. It's almost vertical now.
Yes, because the satellites will be ejected when it is in a vertical position. That is relative to the Earth, of course. There's no up or down in space, but relative to the Earth, once it gets into the vertical position, they will eject the 22 satellites that they're ejecting this evening. Not real satellites, dummy satellites, but 2 of them will are carrying cameras to inspect the ship from outside, to see exactly what's happened to it, and in particular what's happened to the heat shield. So we've got a little time to wait now.
Breaking news.
It's an advert for them.
Wow. Booster crashes on house in Texas. But they're obviously going to need to address that problem with the booster fairly rapidly, aren't they? I don't know whether
they were talking, because there was rumours that they could be going as early as the end of June to test the refueling.
Yeah, that's right.
So, yeah, it's definitely got to be. I don't think that'll happen, but
I wouldn't be
it would
surprised
nice
if that was delayed. Yeah,
absolutely.
Yeah,
you're right.
But I mean, they need to up cadence, so yeah, they need to get that sorted ASAP.
Absolutely. Yeah. So So anyway, don't forget you can support Space Oddities by first of all, buying us a coffee. If you would like us to carry on bringing you the science and live events like this one, then you can buy us a coffee, and you can do so by scanning the QR code here, or you can click the link that's just appeared in the chat. That will take you to our Buy Me a Coffee page, where you can top up our caffeine levels for us, which is always much appreciated. You can, of course, as well, go to the Space Oddities shop and buy your wonderful Space Oddities t-shirts for £20, including UK postage and packing. Wear them with pride, as you should, and equally as you should wear your Space Oddities hoodies with pride. They start at £40, including UK postage and packing. Perfect for these chill spring nights that we're having at the moment. And also, if you would like to make a donation directly to Space Oddities, you can do so by clicking the super chat icon, which is the one underneath the chat window, and that will take you to a place where you can make a donation directly. Also, of course, why don't you join our Patreon? We have a Patreon, and I will put this up on the screen now if I can find it. I can't find it. Not to worry. The Patreon page, very easy, patreon.com/Space Oddities. And for just a few pounds every month, you get lots of goodies. And it's a great way of supporting the channel and allowing us to bring you the straightforward, no-nonsense, factual science that we bring you every week. And all the live events like this, which obviously we're going to continue to bring you, and we will continue obviously with our coverage of the whole Starship program, looking towards next year with Artemis 3, and lots coming up before then. So there we are. Now, also, don't forget that we will be back on Tuesday with our normal Tuesday live stream. If you haven't joined us on the live stream before, come and have some fun. 8 p.m. UK on the channel on Tuesdays. And next Tuesday, Dr. Lou Mayo, who couldn't be with us this evening, will be carrying on his series about planetary migration in the early solar system. So we got that to look forward to next week. And we hope you can join us for that Tuesday and every subsequent one until eternity. So there we are. Right. So anyway, should we go back to the commentary now, Daz? Put the
Yeah, we must be
just
we must be
coming up
on
payload
the
deployment.
Pez
Yeah.
dispenser.
Yeah.
More than 3 decades now. Originally at Rocketdyne, and then at SpaceX during the early years, and
Oh, here we go.
subsequently Virgin Orbit, and now at Astroforge.
Ones anyway.
I've got to ask you, somebody who's been involved since Vulcan 1 engine, what emotions do you feel when you're seeing a launch like this
open.
today?
Yeah.
Oh, it's so exciting. My heart gets pumping every time I see a rocket launch, and Starship is obviously the biggest of them all for that purpose.
We're still waiting at the moment to see if we see those payload deployments. I'll keep an eye on it, and I'll get Alex to make sure he keeps an eye and keep us on that. For you at Astroforge, Robin, what does this vehicle mean for you for the future?
Well, obviously, Starship brings a whole new era for low-cost access to space. Its lift capacity is just ginormous. It's unlike anything that's come before it. But beyond just heavy lift capability, its reusability also brings a level of affordability and continuing to drive down the cost of getting not only to low Earth orbit, but now, as we heard earlier today, alluded to getting to the moon and beyond to Mars. And so it's actually really an exciting time.
Absolutely. Now, obviously, Astroforge are looking to perhaps utilize resources in space. What other industries do you think a vehicle like Spaceship's going to open up to other commercial industries?
Oh, we are.
When we
May
first
I interject for a second here? It seems like we are about to see that payload deployment happen right there.
Yes. Thank you for keeping us honest.
Probably very important for you guys at Astroforge to go through this.
Oh yeah, something's moving.
We are expecting to see about 20 simulated Starlink simulators that are going to possibly deploy today. 2 of them being those Dodger dogs, which we've been laughing about over the last couple of days, named after those LA Dodger hot dogs.
Goodbye.
A bit longer.
This is a view from the flaps of it.
There it goes.
There
Yep.
Oh.
Robin, how
Right.
excited are you that you can see all of this happening as we see this massive rocket
Amazing.
just deploying these satellites? Do you
down,
guys have
20
anything
to
in
go.
mind to deploy something from the press dispenser?
I mean, obviously, as part of this this entire mission, being able to get to see these live images and tremendously high quality. I mean, this is part of what low cost access to space has done for us. It allows people to innovate. It allows companies to get smarter and get more shots on goals, to try different technologies and different approaches. Obviously, this all comes through Starlink, which SpaceX put up, right? I mean, they're their own biggest customer when it comes to these. And in the not too distant future, Starship is going to be able to launch an entire constellation of Starlink satellites in one go, which is just mind-boggling to even think about.
Absolutely. We were asking before we started to see this deployment, the kind of industries that we think this is going to open us up to. And I obviously would love to learn a little bit more about what you guys are doing at AstroForge and what this is going to hopefully entail for you.
Yeah, so obviously my focus these days is on mining resources in space for use here on Earth. That's what AstroForge is about. We're going out to near-Earth asteroids to mine them, specifically platinum group metals. We've already been to deep space once, and we're going to be going again late this year on an Intuitive Machines launch as a ride share for that. Beyond just AstroForge, though, although that's what gets me excited, the reality is all kinds of industries on Earth are impacted by new technology and access to communication. The images that we see coming down from space, the ability to have high bandwidth data transmitted from anywhere in the world, opening up access to the entire human knowledge, database of human knowledge to everyone on planet Earth. It's just absolutely amazing. We're starting to get into, there's been a lot of talk about data centers in space and trying to reduce the impact of these amazing compute capacities that we have today and that continue to grow, removing the environmental impact of that and generating the energy for that in orbit.
And one of the things that I was wondering, Robin, because there was a recent thing from SpaceX that sort of caught my eye that might go right along with what you guys are doing, because they're also talking about space mining and that sort of thing. I guess you guys now have a bit of a bigger competition now with SpaceX, right?
Yeah, so I was actually completely enthusiastic to see that in their recent S&P filing. They did mention that part of their business plan is to use in-space resources. Asteroids, it's actually much easier to get to asteroids and bring material back to Earth from asteroids than it is to go to the moon and bring it back. Although the moon has 1/6 gravity, and that's great for a lot of different applications and research and a great stepping stone for humanity. In terms of bringing material back to Earth, we actually know what's on the moon, and we have a lot of it here on Earth. There's not with the exception of helium-3, there isn't a lot on the moon that is worth bringing back to Earth. Now, using those resources in situ there to make our own moon bases and other applications in space and on the moon, absolutely, that makes a lot of sense. But I was very enthusiastic and excited to see that SpaceX sees the light of being able to go after resources beyond Earth. And as exciting as it is to see rocket launches, I think we all can appreciate that it's much easier to move material around in space than it is to pick it up and launch it off the ground. Even as tremendously large as Starship is, it'll be great to be able to build our large space structures and applications there in space eventually.
I was going to say, we're coming up to those Dodger dogs, those elongated, larger payloads, and we're getting very excited to be able to see that. Alex, can you explain to the people watching what it is that we're about to see when we approach that?
Yeah, they have deployed well over half of those, and now we are getting close to the last. I think there's 4 pairs left, and the final pair of satellites are those Dodger Dogs, the V2 mini satellites, sort of modified to fit in this pest dispenser profile sort of thing, and those are the ones that have the cameras on them. And they're going to be using those to be able to check on the heat shield and trying to develop eventually develop sort of methods to be able to know how that heat shield is before they return the ship, because in the future they're going to go into an orbit, and before returning it over Mexico and Southern California and all those areas before it goes to Starbase, you kind of want to make sure that that ship is ready to go through that reentry. You want to make sure that the heat shield is in good condition to do that. And so it's a really nice thing to develop those methods, because they might be very useful in the future. Shuttle did that, and hopefully in the future the Starship vehicles will be able to use those kinds of methods.
Oh,
Seems like some of the signal is a bit
a bit of a
wonky.
signal issue, but it'll pick up very quickly, I'm sure.
The
Robin,
point they were deploying real Starlinks and not the Starlink dummies that they could use, right?
oh, there is apparently cameras on board those 2 Dodger Dogs. I'm hoping to see some images from those as well, if they are able to do that. Robin, we were talking about the competition, should we call it, competition, but a competitive way, in a good way. It means that it's validating what you guys are going to be looking to do. How close are we to seeing us using space resources right now?
Well, I can tell you that Astroforge is planning to bring material back to Earth, first
Certainly can.
pieces of near-Earth asteroid before the end of this decade. So we've got it takes about.
So, not many to go now.
Yeah,
Nope.
yeah. Okay, so the last two are the ones with the cameras. I assume they'll be able to show live pictures from those cameras, I guess.
Well,
Yeah, I
hopefully,
don't know.
yeah.
It's a bit dark, though. I wonder if they've got lights on them to illuminate the spaceship.
Oh, yeah, interesting.
But I mean, that pest dispenser worked perfectly, didn't it?
It certainly did. I mean,
it looks like it, yeah.
Yeah, it was dispensing 2 at a time this time, whereas before it was 1, wasn't it?
Yeah, that's right.
So, but they're shooting out. They're far more stable than they were before, if you remember. Some of them tilted and sort of like just clipped the doorway. Yeah, that's worked absolutely. I mean, when you think about all the movements that are happening here, all the cogs, the chains, everything that's moving here, it's got to move in a correct sequence to
And
launch these things.
And working in microgravity as well.
Exactly.
Yep.
Exactly. So we go the last 2.
Yeah. And the dispenser is officially empty.
Ooh.
Okay.
So you asked yesterday about the size of the Starlink satellites, Dave.
You're right.
Yeah, I think it's about 3, because that's a 5-meter fairing. So
Okay.
yeah, it's about
That's about right then.
yeah.
Yeah, I guess I didn't realize they were so flat, but that's just because I didn't look.
Yeah, well, they're manufactured in IKEA,
Yeah.
and they sort of self-inflate afterwards.
Okay.
No, they're totally flat for whatever reason. Well, for this reason, I guess, that they
Well, storage for one thing, I suppose, and
Storage, yeah.
dispensing them, right?
Yeah,
is probably-
dispensing,
makes
yeah.
sense.
So there. So we'll now see.
There
Look,
goes the door's closing.
door's closing.
Yep.
They had problems with that on the first flight, but
Yeah.
Oh, okay.
that looks closed. So fantastic. So obviously, a very good party atmosphere at SpaceX. Each of those people contributing something to what we've seen tonight. So well done, and congratulations to everybody.
Yeah, well done.
So yeah, MFI flat pack. That's right, Sandra. Thanks for your donation, Sandra, and to you, Ian. Much appreciated, as always. Every bit of money that we do receive from our viewers at Space Oddities goes towards keeping the channel on the air, as it were. So your donations are particularly appreciated, because we'd love to keep doing what we do for as long as we can. So so there we are. So more and more flap testing by the look of it.
Yep. And it'll probably reorientate itself. We've got next to come up is at 38 minutes 37. We've got the Raptor in space relight demo.
Oh yes, the
okay.
Raptor relight.
Yeah, and then we got a bit of a gap until 47, which is when the Starship starts its re-entry.
Yeah,
and we'll see all the plasma flows and the glowing of everything.
And hopefully no damage to the flaps this time.
Exactly, because they are coming back, as I said, as quite an aggressive angle to test these flats.
It's always been spectacular to see those flaps melting away slowly on descent. But let's hope it doesn't happen. Oh, well, hang on. What are we seeing now? Oh, are we seeing the...
I wonder if this is one of the satellite cameras.
Yeah, I was going to say, is this one of the...
I mean, it almost must be. It's moving, right?
Yes,
I mean, yeah.
Oh, no, hang on. That could be the camera on the flap.
Yeah,
it could be. You're right. It could be.
I don't think it is, though. Oh, maybe. Yeah, I think it's one of the cameras on the flaps. Amazing views.
It certainly is. Well, that was absolutely spectacular so far.
So far, so good.
I'll say 9 out of 10 at the moment.
Yeah. Wow. Yes, if it hadn't been for that over-keen booster flip, then it would have been, well, and the loss of the Raptor on the Starship. The reliability of the Raptors has always been a bit of a problem, but when you think about it, these are the most advanced rocket engines ever built. They're full flow methane oxygen engines, and with the most powerful thrust ever built. So it is taking time to get that right. The sheer pressures inside that engine when it fires are just I can't remember the exact pressure, but it's absolutely frightening. So amazing engineering. And if you look at the difference between the Raptor 1 engine and the Raptor 3 engines, I mean, there's just no comparison. They've chopped off so much mass from the original Raptor. It's quite frightening. Let me see if I can find a graphic of that, actually, while we're waiting for this.
Meanwhile, it's approaching the coast of Africa now.
Yep.
Maybe we'll get some more Earth pictures. That would be cool.
Yeah, absolutely. Okay, so this is what I was talking about. If we look at the 3 versions of the Raptors, there's Raptor 1, Raptor 2, and Raptor 3.
Oh,
and this is how far they're advanced. It has to be said that a lot of the stuff that you're seeing on the Raptor 1 engine is extraneous. It's all sensors, because that was the first version. It was packed full of sensors. But they reduced a lot of those on Raptor 2. And if you look at the Raptor 3, they've actually been very clever. A lot of the fuel lines and what have you that we saw with the Raptor 1 and Raptor 2, they've actually built channels into the metal of the engine itself for those. So instead of having separate pipes and tubes, it's all built into the engine itself. Because as Elon Musk always says, the best part is no part. So the goal, the design goal, is to make everything as simple as possible. And And there we are. So so that's the differences between the Raptor 1, Raptor 2, and Raptor 3. So we're just waiting now. What time did you say the engine relight was going to happen? Was it
37.
Yeah. I think you're on mute, Daz. You are on mute.
Yeah, sorry. The relight demonstration is at what was it, 38:37,
Right.
and the re-entry starts at 47:47. But of course, you just add a sort of like a 30 or 40 seconds either side of that, because it's it's a little bit out at the moment. So
the Raptor relight is just a test. It's not actually needed on this flight, but it's just a test to make sure they can relight the engines in orbit when they need to. So it's been successful so far. They've tried it, I think, 3 times now on previous flights, and it has worked every time. So we're not expecting any major problems with the engine relight tonight. But who knows? Anything could happen in the next half hour.
yeah,
So
it's just a quick flash reignition.
Yeah.
And then they'll orientate themselves ready for the re-entry, and that's when the fun begins.
Yeah. So the spacecraft is now moving at 26,500 kilometers per hour at an altitude of 158 kilometers, and we're just counting down the seconds until the attempted engine relight. They will burn the engine for just a few seconds just to make sure that it relights. So as I said, it is just a test. So don't get worried when that happens. Nothing out of the ordinary. And we're just coming up to that. And don't forget, viewers, if you have any questions at all, please do put them in the comments, and we will see what happens. We haven't seen any of the external shots from the inspector satellites. Maybe we'll get those afterwards.
There'll probably be stills, and they'll probably be downloaded separately.
Yeah. I wondered actually whether they were going to do any infrared photography of the fuselage, because that
they could have infrared on there.
That could be particularly useful for assessing the temperature of the rocket, to see if there are any hot spots or indeed cold spots. So oh right, where are we going now?
Oh, this is from the
this is from the inspector. There we are.
Okay, so that's the
There's
camera.
there's the refueling port on the left. Look,
Yep.
obviously plugged at the moment. But look at that. That's the view from one of those satellites. Wow.
That's the view of it from inside, looking out towards the thing. Yeah.
Oh, there we are.
So cool.
Obviously, a fisheye lens there, by the look of it.
Mm-hmm.
Well, the rocket got more damage than we thought.
Stop that.
Indeed.
Of course, it's the fisheye lenses that they use that actually makes the flat Earth look round. So.
Oh, that's right. Well, that's what they say. Flat Earthers in their stupidity. Yeah. And don't forget the curved windows in aircraft as well.
That's right.
Yeah.
So wow, that's pretty amazing.
That is cool.
Yeah.
To actually be able to see leaving a spaceship in space.
Yeah.
Like that.
And if you look at the panels of tiles on the left there, they seem intact. Don't see any missing there. Amazing.
Absolutely fantastic.
What is that we're watching?
Yeah, that's what I was wondering too. Right? What is all that?
It's
We've
rhythmic.
seen this before when they've been sort of like reorientating things.
Mm.
I don't know if they're reorientating. Yeah, it looks like they're changing the attitude. And I think what you're seeing is the actual vapors from the adjustment jets.
I guess it must be, right?
It's like-
But there's okay. Looks like
Yeah, because they were firing rhythmically. So
Yeah, so
this is the
Yeah.
reorientation now back to a horizontal
Yeah.
position, I suppose.
yeah, as Ian says, it really is very AC Clark.
yeah. Oh well,
Yeah.
that's right. And of course now it's over in the nighttime Earth. So
Yeah.
Yeah.
So does this? I suppose this means we'll be having a daytime splashdown in the Indian Ocean.
Yeah, it'll be a morning one. That's why they that's
Okay.
what they plan for, so they can record it. And remember that the images we've had of the actual splashdowns, each time they've done it, when we've looked at the buoys that they've put out there with the cameras on, the images have got better and better and better. So
We should explain that's boys as in BUOYS,
Yeah.
not some poor kid.
as a marine boy,
Some poor kid in a rowboat.
Yeah.
Yes. You see, you Americans are sensible because you pronounce it buoy. So
Buoy, right.
just make that distinction. Otherwise, we get some very suspect sentences in English. So yeah, Ian says this is very Arthur C. Clarke, and it really, really is.
Yes.
Yeah. I've just taken a delivery of my new book. I'll show it to you. I'll find it. So this is a book called Halcyon Years by Alistair Reynolds. Alistair Reynolds is my favourite sci-fi author. This is the 23rd of his books that I've bought. Many in hardback, actually, because I think he deserved it. Wonderful book. And I thoroughly read. If you're interested in sci-fi, Alistair Reynolds, to my mind, is the canine's testicles. He really is. He's got the most amazing imagination. He worked as an astronomer with the European Space Agency for years, and it's his work is amazing. And this one takes place on a starship that is 50 kilometers across, and there's a whole city inside it. And the hero of the piece is called Yuri Gagarin, and he runs a detective agency. And, bizarre. And he's asked to investigate 2 murders or assumed murders. And then it turns out that he is actually Yuri Gagarin, that after Yuri Gagarin died in that crash, his body was frozen and then centuries later put on a starship and then thawed out. So you've got the original Yuri Gagarin running a detective agency, and it's great. It's actually a lot darker than it at first appears. But he has got an amazing imagination, Alistair Reynolds. Thoroughly recommended to anyone. So there we are. So, right. So, have we had the relight?
it should be around. What did I say?
38, didn't you? 43.
Yeah, 30. I think they. Well, I don't know whether they did. Sometimes they don't bother.
No. Perhaps they skipped it because of the problem with the Raptor earlier. I don't know.
Yeah, probably don't want to.
Haven't seen that. So we're looking now for the start of the descent. Yes, which.
Yeah, that's 47 minutes away.
Right. So what are we seeing now? We're seeing some fuel venting now, I presume. Is it?
I'm not sure about fuel venting or whether or not because it looks like that's reorientating itself again. Because this is the acute angle it's going to come in at.
Yeah.
They really want to stress those rear fins.
Yeah.
And the modifications they've done to them,
Yes,
and also test the new tiles.
Yes, the spacecraft will be entering at a steeper angle than it will when it's in service, just to push it as far as they can in terms of aerodynamics.
Okay.
And don't forget, we'll be back next Tuesday, where Lou Mayo will be carrying on telling us about the migration of planets in the early solar system, which is a really fascinating series. We hope you can join us at 8 p.m. UK on the Space Oddities channel for our normal Tuesday live stream. And don't forget, on Thursday, yesterday, or is it 2 days ago now, we published the latest edition of Space News Weekly, our weekly video where we look at all the latest space news. That's on the channel as well. And along with the 700 other videos that we have on the Space Oddities channel. So there's plenty of stuff for you to watch there, and we hope you enjoy it. And if you do, leave a comment and a like if you would be so good. These comments and likes are very important to us, particularly the comments, because when the YouTube algorithm looks at the video, if it sees lots of comments from people, it recommends that video to other people because it thinks that people are interested in it. If it sees a video with no comments, it thinks people didn't like the video because they weren't even moved to comment. So if you could just leave a comment on this video, whatever you want to say, just hi will do. That would be great. So we do appreciate it, because we have to be slaves to the YouTube algorithm, as every other YouTube channel does. We have to obey by its little foibles and quirks. And one of them is that the more comments we have on videos, the better. It gets our videos recommended to more people in their feeds. So we've got some lovely views now, beautiful colors, as always. And the Starship is actually dropping in altitude now, slowly. And it's now down to 85 kilometers in altitude. And this is the long haul to the Indian Ocean. The Starship will not be recovered. They've never recovered Starships from the Indian Ocean. Not much point, really. And we're seeing the plasma build up now.
Yeah, it looks like it. It's even 80 kilometers.
Yeah.
But the serious stuff starts in a few minutes' time.
Yeah. So we see plasma building up around the vehicle now as it screams down through the atmosphere at a speed of 26,680 kilometers per hour. And this is the cause of these beautiful colored glows around the spacecraft.
And it's definitely speeding up vertically.
Yes, it is. Yeah.
On its way down. It's
on its way down. Yeah.
It's moving.
Yeah.
See, at the moment, the plasma's very low, very not so obvious, but as it starts to hit the more thicker parts of the atmosphere, then it really starts to glow. And then, of course, in the past, you've got to remember, as we've seen, with the earlier tests, that we've seen tiles exploding, breaking apart, and burn throughs and things like that. So we hope to see none of that this time. We're beginning to. Well, it's on its way back. Let's put it that way.
Yeah, it's definitely on its way back.
Yeah.
It's amazing that they can get these rock steady views from Starlink. This is something that we've not seen before with previous spacecraft. We've not seen these beautiful colored views of the plasma and everything else all the way down. But of course, the Starship is so far in one piece, which is what we want.
Yeah, I mean, you can see the speed already dropping.
Yeah, absolutely.
As it gets into the thicker parts of the atmosphere, you can see on the edges, things are beginning to glow.
Yep.
And whereas we've seen these views of the flaps before slowly being eaten away by the plasma and just praying that it would survive until the ground, but the let's hope we don't see that again.
Well, it's like water, isn't it? It looks for any gap that it can get out of.
Yeah, that's
this
right.
plasma to actually start to burn through. And of course, the weakest points were where the flaps actually joined the Starship itself, and then at the ends. I mean, we've seen them where virtually I mean, it's still landed. It's still landed.
Oh yeah,
landing.
well, it's always going to
There's
land.
hardly any of the flap left.
Yeah. So.
Because also what you got to look at is the shiny, the atom metallic areas. You'll see them change color as they heat up.
Yeah. There we are. Ian says Space News Weekly is highly recommended. We'll give you the fiver later, Ian. Thank you very much for saying that. We do try. So Space News Weekly, we publish every Thursday on the channel, all the very latest space news. As you may know, it used to be part of our Tuesday live stream, but we split it into its own program now. So look out for Space News Weekly on the channel every Thursday. I normally publish it sometime Thursday evening. And keep up to date with all the very, very latest space exploration, astronomy, cosmology, astrophysics, etc. news. And if you like it, please leave a comment, because as I said, those comments are kind of important for getting our videos recommended to people. Thank you. Beautiful colors.
Yeah, well, we're definitely into the re-entry thing, because we're 51 minutes into it now, so we're definitely getting to the hard bit.
And it's slowed down dramatically.
Yeah.
As far as its altitude changes.
Yeah, absolutely.
It was just ticking off, and now it is. I mean, well, it looks like it's barely moving. Obviously, it's moving really fast, but it's a lot slower.
Although the altitude just went up again.
Yeah, they're using the flap to gain some lift.
Yeah, that's right. Yeah. And don't forget, we're seeing this from inside the intensely hot plasma surrounding the spacecraft. But not just that, we're getting 4K video from it, which is quite amazing. So this is going to look great on my TV. No apparent damage yet to the flaps.
No, everything looks really nice.
Everything looks good.
Yeah, it is. It is going up again, or at least it was. Now maybe. So is that what it was? I mean, it's skipping a little bit. Is that what's happening?
Yes, I
It
think
seems to be. I think they're just
I mean, it's a
They're just using the flaps to slow it down, basically, aren't they? By skipping it up and down to lose velocity.
Mm-hmm. Okay, now it's going down again.
Yeah. Or perhaps they just want to keep it in level flight and until they get closer to the Pacific. Sorry, the Indian Ocean.
The Indian Ocean, right? Well, and actually, it's according to the little globe down at the bottom there, it's well into the Indian Ocean.
It is.
I guess it's gonna have to get vertical pretty soon, dropping or.
Oh no! It only does that in the last few hundred meters.
Yeah, literally.
Yeah.
Well, I meant the trajectory, not the orientation, I suppose.
Oh right.
Yeah, because it's due to go transonic about 1 minute, 1 hour, 2 minutes, 29 seconds.
Right. So we've got about 7 or 8 minutes yet.
Yeah, and then subsonic at 1 hour, 3 minutes and 8 seconds.
Okay.
Right. So we've got about another 10 minutes of the flight left. Then.
Yeah, and then we've got at 1 hour 5 and 6 seconds, we'll get the landing burn. And then you get the landing flip at 1 hour, 5 minutes and 8 seconds. So when it starts its landing burn, that's when it'll do its final flip.
Yeah. I remember seeing the first time it did that flip was terrifying.
Yeah, it does it so quickly.
Yeah, everybody said it would never work, but SpaceX knew better. So it's funny. I always find it amazing when we get advances like this, and people say, "Oh no, that'll never work. That'll never work," and then
And it probably doesn't for the first couple of times, but they make it work.
I had that situation with my brother-in-law. We had a bet over the sky crane on Mars that wouldn't land the Curiosity rover in one piece. My brother-in-law was insistent. My brother-in-law's an engineer, and he said, "No, that'll never work. That'll never work." And we had a £20 bet that it would work, and it did, and I won. So
Yep.
And that was quite amazing. Personally, I had my own reservations and it wouldn't work. But I wasn't going to let him bet.
Everyone was sweating it, I guess. But
yeah, the 7 minutes of terror.
Right.
We've seen some amazing things in space the last few years that you would look at and think, no, that'll never work in a month of Sundays. And it does. So we can see now the camera, which is mounted on the flap, is moving because the flaps are starting to dig into the upper atmosphere now, and control the aerodynamic descent of the vehicle. We are now under 20,000 kilometers an hour in speed at an altitude of about 58 kilometers. And so far, no problems. Fingers
just
crossed.
Looking at the catch pin, if you look on it just here on the top left, it's beginning to glow a bit with a bit of plasma on there.
And we are looking at temperatures here of a couple of thousand degrees. Yeah. So this is why it glows, because it's plasma.
Yeah. Seems we've got a bit of ablation going on.
I don't know. So assuming that this splashes down okay, and we've got no reason to think it won't at the moment, in terms of mission objectives, what do you think?
Yeah, I mean, I suppose we could actually be interested to see whether they can get it on target for the splashdown, because, like I said, they had probably a slower ascent with that one rocket out, although they could adjust it. Let's just hope they got enough fuel for the landing burn.
Yeah,
because they had to burn them just a little bit longer.
Oh yes, but don't forget that the landing burn comes from a separate tank. Comes from the header tank. So
yeah, well remembered.
There we are. That's my middle name.
Well, they have to be pretty happy with how this is going.
Yes, I think so.
You know, you got to figure that's not going to work perfectly, but that's.
I think it's close enough. I mean,
oh yeah, no. This is like I said, they've got to be pretty happy with this.
I think NASA will be happy that at least progress is being made, and you know, it's a brand new vehicle, brand new launch complex. So, you know, everything has gone pretty much to plan, although we don't know exactly what went wrong with the booster. Apart from the fact it was over keen to do its head over heels.
You can see we're coming into daylight now, if you look at the top.
Yeah.
But these flaps look absolutely amazing. They're not...
There doesn't appear to be any damage at all to the flaps.
No.
Which is stunning.
Yeah.
Paul says they clearly need to improve the reliability of the Raptors. Absolutely. But they can't do it without testing them, of course. So, you know, it's incremental.
We're seeing some of the Earth now. Okay, I like that.
You're right, Paul. They do need to nail the reliability of the Raptors, but I'm sure they can. They're clever people. They've got this far. I mean, to be fair, it's the first time in quite a few flights that we've lost any Raptors.
Yeah, exactly. I was surprised we lost a Raptor on the way up.
Yeah,
with the booster. But then they said they're new engines, so we should we shouldn't be surprised at all that there's been a few teething problems. But as I said, at the moment, it's a 9 out of 10. So, we're just coming up to transonic. A couple of minutes away from there. I mean, you imagine all the data they're going to get off of this. So, and that's what it's all about, isn't it? Just get the data back, check your data, and adapt. I mean, they look perfect, don't they?
Mm-hmm.
Yeah, they do. Yeah, it was on flight 10 when we lost a Raptor on the way up last.
Leon's asking, is it normal to lose transmission during re-entry? If this was a sort of like a standard type capsule, then yes. But because of the as he was saying earlier on, and how this vehicle re-enters, it actually thought there's a small gap on the backside of the vehicle, which the plasma doesn't fill, and they can actually then transmit using Starlinks to get these images. So we may get occasional dropout, but that's usually because the satellites, there's probably a gap between the satellites, so they can. But we won't have a complete like radio blackout or anything like that, Leon. So thanks for the question.
Well, it's through it. It's no more plasma glowing.
No. So we're now
36,
transonic.
36 kilometers in altitude.
Soon to be subsonic.
Yeah.
And 2 minutes later, we should get a landing burn. Fingers crossed. So, to be honest, I think that was you couldn't have expected any better re-entry through the actual atmosphere. We saw none of the glows, none of the burn-throughs. There was obviously a bit of ablation going on somewhere, but it's obviously nothing's burnt through. I did notice that with with these tiles at the front earlier on, you could actually see a glow in the gaps.
Right. Yeah. But no damage, apparently.
No damage, yeah.
Yeah. Joseph says, do you plan on seeing a test in person? Daz,
if we
see a test?
if you start a GoFundMe.
Exactly. Yeah. I'm not sure my pension will stretch to that, but I would love to. Maybe. I mean, I think rather than go to a test when you could go all the way to see a test and it blows up or something, I would rather wait till Starship enters service and is reliable, so that you spend all that money and go all that way, then you're almost guaranteed success. But I'm not ruling it out, Joseph. I would love to. I've never seen a live launch, and
we're subsonic now.
We're subsonic, fantastic.
Yeah. So I'm just listing on another feed.
Years ago, I had well-developed plans to go and see a shuttle launch with my boss at the time, and we got all these plans to fly to see a launch of the shuttle, and at the last moment we couldn't go because his wife wouldn't let him. So,
Oh,
yeah, I was absolutely gutted. Luckily, I hadn't got round to buying the flights, but it was all our plans. And his wife said, "You're not going. You're not spending all that money going to see something stupid like a shuttle launch." So,
Oh boy.
Just doesn't understand.
no,
no.
he just said, "Okay, darling."
I've never seen one launch, but I've seen a couple of them land
Yeah.
out in the desert at Edwards Air Force Base.
Oh, have you?
That is something. Yeah, that's something to see. You know how they it's the cliche that it drops out of the sky like a rock, and that is what it looks like. I mean, you know, everyone's looking. There's like thousands of people out in the desert, and everyone's looking up. You hear the booms and everything, and then someone goes, "There it is!" And then you can see this little dot, and it just grows so fast. And then it finally flattens out and goes flying down across the desert floor. It's pretty spectacular.
Turning now to point towards the landing site.
Yeah.
Beautiful day.
It certainly is.
Yes, coming on 3 kilometers, huh? It's
well, it's always going to be beautiful above the clouds, isn't it?
Yeah. And please remember, everybody, when this hits the water, it probably will explode.
Oh, yes.
What you've got to remember is this thing is absolutely boiling. It's red hot. And of course, once it hits the cold sea, everything ruptures. Oh, here we go.
Oh, look. Wow.
Whoops.
Oh.
Here's the landing burn.
Yep. Here we go. There it is.
Oh, you can't really see much.
Wait for the explosion. Although they often cut away before.
There it goes. Oh, look.
It's falling over.
Ah, there we go.
Yeah, you called it.
Well done. Well done.
Yay.
Wow.
Oh, lovely mushroom cloud.
Wow.
Well, that's more than we normally see.
Yeah, they normally cut away before that.
Yeah.
Yeah.
I bet the wildlife people want to know how many sharks that killed.
Yeah.
Remember all that kerfuffle?
I don't want to go through that again.
Yeah. But that was absolutely fantastic. Well done.
Yeah, so fantastic.
I mean, those images of it actually landing, and they had a drone literally sat on top of it.
I know.
Yep.
Absolutely fantastic.
And it you know, we've seen starships return and do exactly that maneuver, splashing down in the Indian Ocean, looking rather the worst for wear, but that didn't. That looked perfect.
Pretty good. Yeah.
Yeah. Do you remember? Do you remember when it turned bright red?
Yeah.
Yeah.
Because they were experimenting with using metal heat shield tiles, and they put some on the Starship and they oxidized them, and the oxidation ran all down the side of the spacecraft and made turn the Starship red. And they didn't try those metal tiles again because obviously that would stick.
Wow.
So there we are. All right then.
Fantastic. Fantastic.
Well, wow. Okay.
Starship Flight 12 over with. We look forward now to Flight 13.
Yep.
I wonder if they're going to number it 13 or go straight to 14. I wonder how superstitious they are. Yeah, why did it? Good question, Alvaro. And why did it have to blow? Well, what happens is that because they're splashing down, this is what happens when cold seawater hits incredibly cold, incredibly hot fuel tanks, and it just ignites them, and it's just the seawater causing the explosion. But you know, obviously, when the Starship does get into normal service, that won't happen. But we kind of look forward to it. It's a nice, spectacular end to the mission, really.
Yeah.
So completely normal when that's cold seawater gets into the fuel tanks and bang. So there you are. Barry says this was probably the smoothest re-entry so far. Yeah, absolutely. It was definitely.
I'm with you, Barry. I'm absolutely with you with that.
So they've made great strides in improving the re-entry procedure, and with the new Block 3, they proved that they can do it without damaging the spacecraft. And when you think about it, they have just achieved something that no other company or agency has done in history. They've created a reusable heat shield that they can fly again without having to replace it. Because if you remember the space shuttle, that had to have virtually its entire heat shield replaced between flights, because each of the tiles was individually cut to fill a particularly shaped gap. And this is why it took so long to refurbish the shuttles. But with the Starship, the tiles are hexagonal. They tessellate rather nicely, and they can be easily replaced in a few minutes. So they've actually...
It's a replay.
Oh, there's
replay of the launch.
Yeah.
Wow.
A lot of water there. Whoa.
Yeah, that is. That water is something, but I suppose it produces a lot more steam than we're used to seeing, and so it hides a lot of the launch.
Exactly. I mean, also this. Look at the
shockwaves. Look at the shockwaves
fluctuating from the shockwaves. But this is why I like NASA Spaceway, because they got cameras from all directions.
Yeah, they got loads of cameras.
Yeah.
I mean, look at that go.
You can see the shockwaves in the air. Look to the right.
Yes. That's spectacular, and right. And it's
and as I said earlier, you're looking at more thrust than the Saturn V and the SLS combined. Most of what you're seeing there is steam, and there we are, and a perfect.
They're also replaying up in the top left the Pez dispenser.
Oh yeah.
Yep.
But listen to that crackle.
In the top middle, you can see the original Starhopper that they kept sentimental about.
Yeah.
It's actually now.
I did notice yesterday when they showed an overhead shot, it's actually got its own little car park around it now.
Oh, has it?
Is that right?
Oh, you can see a car there. Yeah. Well, that's now a permanent fixture of Starbase. This was the vehicle that they used to test the first Raptor engine that went up to 50 meters or something. I think it was only 50 meters, and came back down again just to test the first Raptor.
Yeah.
But it's a permanent fixture of Starbase now, because it's got cameras and weather monitoring equipment on it, so it's serving another purpose now.
And also with the very first Starship launch, it got peppered with debris, and it's got holes.
Yes, that's right. It's got rather.
I mean, like everything else, and it's like a mile radius.
Yeah.
Oh, that's funny.
And there we are. There's another replay. Look.
Mm.
There goes the water. And there go the Raptors.
Yeah.
God, you just can't imagine that force, can you? Absolutely unbelievable.
There goes.
Yeah, that's true.
Shockwaves there.
Yeah. Wow. All right then. I think we will leave you for this evening. Listen, viewers, thank you for staying up with us. Thank you for watching us tonight. We do appreciate it, and thank you for your donations. It's been great to be with you all. Don't forget, we'll be back on Tuesday. Check out this week's Space News Weekly for all the latest space news, which is already on the channel. And we hope to see you next Tuesday at 8 p.m. UK time on the channel for our normal Tuesday live stream, when hopefully Lou will be back and Michael will be back. And we might even get Tom showing up. So there you are. Stranger things happen at sea, as they say. So from all of us at Space Oddities, thank you so much for watching. Have a fantastic weekend. Take care, and thank you for being here. So from all of us, a very good night to you.
Take care. Good night.